Hello, welcome to Statistics for Data Science. In this module, we are going to be seeing about some of the basics of statistics that are required for machine learning and predictive analytics uses. So the goals of this particular module is basically to describe the basic statistics that are required for data science. Very simple level that we are going to deal with. We're going to explain the concepts at a very high level and at a very simple way. We're going to avoid formulae and mathematical representations as much as possible. We want to just keep it simple so that everyone who with different levels of mathematical exposure can understand what is going on. So I hope this is going to be useful to you. And if you feel you want to learn more about that, there are other courses and other material for that. We are trying to avoid them in this course so that we want to keep it the minimum possible for everybody. We go into what are the types of data and what are they and what we want to do with them. Types of data play a very important role in data science because machine learning algorithms typically are impacted by what type of data are being passed to them. So some machine learning algorithms are good with some types of data, which is what we will see in the predictive analytics module. So it is good to learn what these type of data are and what you can do with them. So there are four types of data typically you deal with, and they typically differ in the meaning and the operations that you can basically do on them. And these four types of data are called categorical data or nominal data or factors. The second type is ordinal data, third is interval, and the fourth is called ratio. So what exactly are these? Let us start with categorical. Categorical data represents categories or types. We have been seeing types and categories all over the place. The best example of categorical data is gender being male or female. So what is special about this categorical data in that there is always a fixed set of values. Like in the case of gender, there is just male and female. It has no implicit ordering or sequencing. You cannot sequence them or order them in any way saying one is better than the other or one is higher than the other. So all of them are considered equal. You can't really compare them like with a greater than or a lesser than symbol in the case of categorical data. Some of the examples are like the list of fruits like apples, oranges, grapes. In a soccer team, you can have different types of players like defender, midfielder, forward, or you have types of cars like sedan, SUV, coupe, etc. As you can see, they are just categories. They all typically have a fixed set of values, and you do not have any kind of implicit ordering or sequencing among them. The second type of data is called ordinal data, which also pretty much is like categorical data in that it also has like a fixed set of values, but there is ordering among these values. You can actually order them and say one is better than the other or one is higher than the other. And they typically represent a scale of measurement, like a scale of 1 to 10, a scale of 1 to 5, or something like high, medium, low, excellent, very good, good. It usually represents a scale, but it is still categorical data. And you can do comparisons, like you can do greater than or less than kind of comparisons, but you cannot do any kind of arithmetic operations like addition, subtraction, multiplication, division on each of them. Some of the examples you can see is like review ratings, like outstanding, very good, good. That's an example of an ordinal data. Pain levels, 10 being the highest, like 1 to 10. Student grades, A, B, C, D, E, F, where A is the highest. So you always have something like the highest and lowest. You can actually compare them as compared to categorical data. The third type of data we will be dealing with is called the interval data. So interval data is typically numeric data. And measurement, it is measurement where the difference between the numbers has some meaning, like a distance, for example. Suppose a distance between point A and B is 60 miles, between B and C is 70 miles. The distance is 10 miles, and the distance 10 miles is a meaningful number, a meaningful distance. So in an interval data, there is meaning with reference to the distance here. represents things like time, distance, temperature, these kind of stuff. The most important thing you want to note is that addition and subtraction is possible. Like you can add time or subtract time, add distances, add temperatures. But multiplication and division are not possible. You cannot multiply distance 1 and distance 2 and get another distance. You will always get distance squared. It doesn't make sense to multiply and divide distances. So that is what it means. Examples are like time of the day, dates, distance between 2 points, temperature, and things like that. This is interval data. And the last type you would see is what is called the ratio data. The ratio data is everything else, like any kind of numeric data that you would see that doesn't qualify as as any of the other three types of data we just saw. All kinds of arithmetic operations are possible with ratio data. A true zero is possible, where zero is a true valid value in the case of a ratio data. Some examples of these are like weight, speed, amount. Any kind of continuous measurement data that you would see in real life is considered ratio data. So how do they all compare? Here is a nice comparison chart between each of the four types. Discrete values are applicable in all the four of them. Continuous values are applicable only in interval and ratio data, because ordinal and nominal are just categories. Frequency distributions, we will see later, are applicable for actually all of them. Median and percentiles, though, are applicable only for interval, ratio, and ordinal. Sorry for the red being on the yes and ordinal and median and percentages. Addition and subtraction are possible with interval and ratio data. Multiplication and division is only possible on ratio. Mean and standard deviation, again, we are going to be looking at what they are in the future sessions. They are applicable only on interval and ratio. And of course, you can find real ratios, like ratio between A and B in ratio data only, and a true zero is applicable only in the case of ratio data. So this is how they all compare with each other. I hope this presentation helps you in understanding what the various types of data are. Thank you.